Hi guys, we are back with another video that is going to be based on resonance in tubes and resonance in strings, right? So in this, of course, we will be discussing few questions in these two parts, right? Resonance in strings and resonance in tubes. All right. So the first few questions are pretty easy. So I'll be moving on to few good questions. So let us see the 10th question. We'll see what it says. It says for a resonance tube, the air column for the first and the second, first and the second resonances, which means the first and the second resonances, right? First resonance and the second resonance, right? Which means the fundamental and first overtone differ in length 31.5 centimeters, the wavelength of the wave, right? For a resonance tube, the air column for the first and the second resonances differ in length by 31 centimeters. So what it says, is it a one end closed tube or open end tube? Yeah, so the thing is, they should have mentioned actually whether this is a one end tube or a one end closed tube or an open end tube. For the time being, let's try this problem, mention it in this way, right? So, right, for a, maybe we can say one end closed, right? For a one end closed resonance tube, the air column of the first and the second resonance differ. Okay, so we can easily try this problem out. So since this is a one end closed tube, right, the first resonance is going to be this kind of a waveform, right? So the length, for example, the length is going to be what? L1 is going to be pi over 4, right? L1 is going to be pi over 4. We obviously know that. And this is the first resonance, right? This is the first resonance. So what about the second resonance? What about the second resonance? What about the second resonance? Second resonance is going to take this kind of a format, right? The second resonance is going to be this kind of format, which means like if we mark the length to be as L2, right? If the mark of mark of the tube, length of the tube is L2, so then L2 is going to be what? So here this is pi over 2, this is pi over 2, this is pi over 4. If you see, this is going to be 3 pi over 4, right? So they have told that the difference in length, right? What do they say? Difference in length, first and the second. So the difference in length, which means this is the second overtone, right? The difference in length L2 minus L1 is 31.5 centimeters. What is L2? 3 pi over 4 minus 5 pi over, so lambda over 5, right? 31.5, which means here it's going to be what? If you simplify further, 2 lambda over 4, 31.5, lambda over 2, 31.5, right? Lambda is going to be what? Lambda is going to be 63, right? Lambda is going to be 63 centimeters. So let's see whether there is an answer. Such an answer. Yeah, 63 centimeters. So make sure to correct this, right? One end closed tube. Like if you do this in a different approach, I mean like for a open end tube, so these things would change, right? So initially for the first resonance, it is going to be lambda over 2, and for the second resonance, it's going to be lambda. So when you get the difference, it's not going to be lambda over 2, it's going to be lambda, right? So sorry, it's going to be lambda over 2. It's still the same, right? Still the same, I guess. Yeah, this is lambda. Like if it is an open end tube, let's check whether it's the same. So if it's an open end tube, right? It's like this, right? So L1 is lambda over 2, right? If it is the second first overtone, which means the second resonance is the first overtone, right? So forgive me for the drawings, right? So it's not very accurate. L2 is what? So this is lambda over 2 and the lambda over 4, which means it is totally going to be lambda, right? So if you get the difference, once again, still it's L2 minus L1, still it's going to be lambda minus lambda over 2, right? If you see, it's lambda over 2. So 31.5 lambda over 2. Still, its lambda is going to be, right? Lambda is going to be what? 63 centimeters, right? So it doesn't matter whether it's a one end closed tube or open end tube. So like we will erase this, right? It doesn't matter, right? So definitely the answer is going to be 63, right? So right, let's go for the 12th question. Here the thing is like so the 11th question is a beats problem, so I will not do that. So let us go for the 12th one. So it says the first overtone of an open pipe. So first overtone of an open pipe organ tube has the same frequency as the right? So has the same frequency as the first overtone of a closed pipe 3 meter long. Closed pipe which is 3 meters long. The length of the open pipe is what they are asking, right? So the question is the 12th one, right? What I would do is fine. So it's like this. They are saying, right? So what they're saying is uh, it's like this. They have given us a uh, closed pipe, right? They have given us a closed pipe and open pipe, right? They have given us a closed pipe and open pipe. Let's assume the length of the closed pipe is L1, right? Let's assume the length of the closed pipe is L1 and the length of the open pipe is L2, right? Let's assume that is L2. So the thing is, both somehow has the for the first overtone, right? Shall we write an expression for the first overtone? The first overtone, we can write the first overtone of this guy, F closed, FC1, right? First overtone. How do we write? How do we write the first overtone? So the first overtone drawing is going to be what? So you do not have to remember these things, but still better remember, right? So you do not have to know the drawing to do this question. But right, okay, fine. So we know it is 3v over 3v over what? 3v over 4L1 first overtone, right? This the first overtone of the open end tube is what? First overtone of the open end tube is V over L2, right? V over L2, right? V over L2, right? So like we know the common equations. From the common equations also we can come Fn is equal to 2n plus 1 F naught, right? So here Fn is equal to what? N plus 1 F naught, right? So what do you need to know is F naught and like F naught of a closed tube and F naught of a open tube, right? So the F naught of a closed tube is 4 V over 4L1, V over 4L1. The free open the fundamental frequency of an open end tube is V over 2L 2L2, right? So and then if you need the first order, you have to put 4N1, right? So 1, okay, 2 plus 1 is 3, 3F naught. Yeah, okay, 3F naught. This is 1 plus 1 is 2F naught, 2F naught, right? Okay, fine. What they're saying is both these frequencies are same, it seems. They have given that both these frequencies are same. If that is the case, what is it going to be? 3V over 4L1 V over L2. The velocity of sound in air is going to be always the same, right? It doesn't change. Which means now we have an expression that is L2 is equal to 3 over 4. But L2 is equal to not 3 over 4. Actually, it is L2 is equal to, we can say L2 is equal to 4L1 over 3, right? So L2 is this open pipes, this thing. So closed pipe's length is 3 meters. The closed pipe is L1, that is given to be as 3 meters. So L2 is equal to 4 into 3 meters divided by 3. 3 to 3 cancels, right? Cancels. So L2 is going to be given as 4 meters. So is there such an answer, guys? If we see 4 meters, yes, there is an answer, right? So all right, guys, let's go for the 15th one. As the rest of them were beats problems, right? The 15th one, it says a metal wire. Yeah, this is also the same. Okay, this is also a beats problem. The 16th one. Let's go for the 16th one. It says the fundamental frequency of right? Fundamental frequency of 1.5 meter long stretched wire. Stretched wire is 175. The length of it is 1.5 meters. So they are asking, first of all, calculate the speed of transverse wave, right? So we have to find the speed of transverse wave, right? Fine. So let us go for the speed of transverse waves. All right. What we could do here is, right, so we need to find the speed of transverse waves, right? So this is the 16th problem. So it's like this: speed of transverse wave. This is like it's a it's a stretched wire, right? A fundamental waveform is going to be there. How will the fundamental waveform going to be shown? So it's going to be this kind of a waveform, right? So fundamental waveform of a stretched string is F naught is equal to V over what, 2L, right? So they have given, like, we need the speed. V is equal to 2L into F naught. They have given F naught. F naught is what? F naught is 175 hertz and length is 1.5, right? So V is equal to 2 into 1.5 into 175. If you simplify this, I think you will get something around the given answer, 525, right? 525 meters per second, right? Okay, that is fine. And then they are asking to find us the longitudinal stress T over A in the wire. They are asking to find us the longitudinal stress T over A in the wire. How would we find that? Longitudinal stress, this is the tension, right? This is the tension, and the cross-sectional area is A. We need to find the longitudinal stress. So we can find that by using the equation that we have for the velocity. The fundamental equation that we have for the velocity is what? Velocity of speed of a transverse wave in a stretched string is T over simple M. Simple M is mass per unit length, right? So further you can write what? T, mass per unit length, you can write capital M over L, right? You can write it as capital M over L, like the total mass of the wire, the total mass of the wire, and divide by the length of the wire, right? So that is mass per unit length. So the velocity, further you can write it as what? Tension, length, right? Divide by mass, round. Further, you can write T, L. You can write mass how? Mass can be written as density into volume. Density into volume, right? So this is volume, not velocity. Density into volume. So further you can write T, L, rho. Volume you can write how? Volume of the string. Volume of the string you can write how? Cross-sectional area into the length. Volume of the string is the cross-sectional area into the length, right? So as the volume, I will write cross-sectional area into length. So this cancels out. So what is going to remain is V is equal to root T over rho A. So if we square both sides, V squared is equal to T over rho A. And if what we need is T over A, so if we subject T over A, right? T over A is equal to V squared into rho, right? So we can find T over A. We know V squared 525 squared. What is the density of the material? Density of steel is 8 into 10 to the power 3. 8 into 10 to the power 3, right? 8 into 10 to the power 3. If you do that, right, you're going to get the final value to be as T over A is equal to, let's write down the simplified answer, 2.205 into the power 3, right? 2.205 into 10 to the power 3, right? So this would be the answer, newtons per square meter. This would be the value. And then they are saying in the B part, right? In the B part, if the tension in the wire, right? If the tension in the wire is increased by 3%, if the tension in the wire is increased by 3%, calculate the percentage change in the frequency of the wire. Percentage change in the frequency of the wire. Okay, if the tension is increased by 3%, simply, frequency is what? Frequency is equal to, frequency we can write it as frequency is equal to what? If we write V over, right? What V over 2L, right? Frequency further can be written as 1 over 2L divided by root T over M, right? Root T over M, right? Percentage change in frequency of the wire. So now, now they are increasing this by 3%. If they are increasing this by 3%, right? That they're increasing the tension by 3%. All right. So now the tension is going to be what? The tension is going to be 103, like new frequency. New frequency is what? The new frequency, F new. The new frequency is 1 over 2L. The tension is now 103T over 100 into M, because like if it is increased by 3%, it should be 103T over, like 103 times the 103 over 100 times that of the previous T, right? This is 3%. This is 3%, you know, right? So let's assume this is the first equation, right? This is the second equation. So what you need is the percentage. What you need is the percentage change. Calculate the percentage change in the frequency of the wire. Percentage change. It's like this: delta F over F into 100%. This is the percentage change of frequency. The change of frequency over initial frequency into 100%. I'm not going to simplify this, right? I'll just write, right? What is the delta F? What is the delta F? Delta F means you can write delta F as F new, right? F new minus initial frequency over frequency into 100%. You have F new. You have F new, right? You have the old frequency also, right? And divide by the current frequency, and then simplify. You're going to get something around very close to 1.5 percentage, right? You will be getting something around 1.5 percentage, right? So this would be the answer. All right, this would be the answer. Fine. So just simplify. I'm not going to simplify because I have given you all the values, right? So you can apply it here, right? So you can apply this here and then this here, and then if you simplify, I'm going to get something closer to this value, right? So this is simply simplifications, but to be honest, like that, there might be other methods also to solve this problem, this part, right? So I guess there would be easier methods to solve this. For the time being, of course, I chose this method, but you can go with different other methods, other approaches also, right? So yes, that is done in that case. Right. So let us move on to the 17th problem. So this says when an open pipe is suddenly closed. Right here, when an open pipe is suddenly closed, it is found that the second overtone of the closed pipe is higher than the frequency by 100% than the first overtone. Right. This is completely English. Of course, you have to understand. Like, I mean, they might have tried to how do I say, to complicate you, to confuse you, right? But this is not a very difficult question if you understand English behind this. So what they're saying is when an open pipe is suddenly closed, it is found that the second overtone of the closed pipe, right? Okay, second overtone of the closed pipe, right? Second overtone of the closed pipe, right? Second overtone of the closed pipe. Second overtone I will write second F2, second overtone of the closed pipe. Okay, second overtone of the closed pipe is 100 hertz higher than the first overtone of the open pipe. Is 100 hertz higher than the first overtone of the open open original open pipe. So this is the relationship, right? So what is F2C? Like for a closed pipe, closed pipe, you do not have to remember these things, but you need to remember the common equation 2n plus 1 F naught, right? So for a closed pipe, second overtone is what? F2C. For a closed pipe, second overtone. For n apply 2, right? N apply 2, 5 F fundamental of closed. F fundamental of closed. So when it comes to open tubes, right? Open pipe, right? the fundamental equation is n plus 1 f not open, right? So we need the first overtone here. So f1, first overtone of the fundamental, not the fundamental, open tube. So it is 2f naught of the open end tube. So f2, second overtone of the closed tube is what? 5 times the fundamental of closed tube. 100, right? Plus first overtone of the open tube. First overtone of the open tube is the second fundamental of the open tube. Right now we will write the fundamental frequency of the open closed tube. Fundamental frequency of the closed tube is V over 4L, right? 100 2 times fundamental of the closed tube is what? Fundamental of the open tube. Fundamental of the open tube is V over 2L. The same tube is used, right? So the length is the same. It's the same tube you are closing and opening. So then the length are the same, right? So here we're going to get, if we simplify this further, right? This to this cancels. So 5V over 4L. If we take this to this side, V over L is equal to 100. And further, if you take V over L out, right? So 5 over 4 minus 1, right, is equal to 100. In that case, you're going to get V over 4L. V over 4L is equal to 100 hertz. V over 4L, right? If you can simplify and see V over 4L. So what they are asking is the fundamental frequency of the open pipe. This is what the fundamental frequency of so what is the fundamental frequency of an open pipe? Fundamental frequency of an open pipe is what? It is V over 2L. So how can we make this V over 2L? Multiply both sides by 2. Multiply both sides by 2. In that case, this is going to get cancelled and you are going to get V over 2L. V over 2L is fundamental of the open tube. Is going to be 200 hertz. So the answer is going to be, as mentioned, 200 hertz, right? Right. So the 18th, 19th, 20th, and 21st questions are going to be beat frequency questions. So I will skip them and move on to the 22nd problem. We'll say this is somewhat different actually. Two closed pipes of the same diameter, and two closed pipes of the same diameter, right? Closed pipes of the same diameter produces nodes which are an octave apart. Octave apart. We'll come to what an octave means, right? If the lengths of the pipes are 62 and 30, what are the end corrections? So it's like this. Octave apart means like it's something like this. So an octave apart means 21, right? So it's like this. For example, if this is one end closed tube and this is the other tube, right? If the frequency produced by this is f, then the frequency produced by this is 2f. Then we say these two are an octave apart, right? So I don't think you're going to get this kind. Like better know these concepts, right? Like it's something in addition, right? So, but it's not a very big thing. They could give it as okay. So assume now they have not given the word octave, and then they have given the word the phrase that the frequency of one tube is double the frequency of the other. Like okay, so let's assume it in that way, right? Somehow when it is an octave apart, the frequency produced by one tube is double the frequency produced by the other tube. Let's assume this is L1 and this is L2, right? They have given the lengths L1 and L2, right? L2, let's say 62 centimeters or something, and L1 was 30 30 centimeters, if I am correct. Yeah, 30 centimeters, right? So it should be the other way around, because like the tube which has the lower length has the higher frequency, you know, and so f is equal to from f is equal to v over 2l, v over 4l, right? So when l is low, f is high. So that is why I since this is 2f, I gave it as 30. So there is an end correction also, right? There is an end correction also. All right, there is and end correction also. So do we know exactly which, how do I say, do we know exactly which overtone this is? Is it a fundamental frequency or else an overtone? No, they have not mentioned anything about an overtone. So therefore we will have to consider this as Fn, right? We'll have to consider this as Fn, then this is 2Fn, right? So right, so simply if it is since it is an octave, Fn is equal to 2Fn. Fn, how do we write? 2n plus 1 F, no, this is 2 times F, 2n plus Fn, and Fn simply the fundamental frequency, the fundamental, yeah, they have told the fundamental, so we can consider this as Fn. Yeah, we can consider this as if we can consider this to be as something like Fn, and this to be as Fn dash. Since it is an octave apart, Fn dash is 2Fn, right? Fn dash is 2Fn, right? So let's use that since it is Fn dash is 2Fn, right? Yes. So Fn dash, how do we write Fn dash? Fn dash is going to be what? V over 4. L is 30 centimeters plus 30 plus E, right? Since the diameter is the same, it's not going to be E1 and E2. Like if they have not mentioned anything about the diameter, then this should be E1 and this should be E2. But here they have told the diameter is the same. So therefore EE, the end correction of a one end closed tube depends only on, like, it doesn't matter one end or two open end tubes, the end correction always depends only on the diameter. If the diameter is the same, the end correction is the same, right? So 30 plus, okay, E is equal to 2 times, what is the fundamental frequency? V over 4 times, in that case, 62 plus E, right? So here if we see V2, V cancels, 4 to 4 cancels, right? So 62 plus E is equal to 2 times 30 plus E. So 62 plus E is 60 plus 2E. So if you see, take this to this side, 62 minus 60 and 2E minus E. So E is equal to 2 centimeters, right? So simple, this simple, right? So like if you assume this has Fn and Fn dash, so Fn is like it can be any frequency, right? 2 times, sorry, 2n plus 1 F naught, right? Fn dash can be what? Fn dash can be any frequency, common frequency, 2n plus 1, it's common fundamental frequency. So here, when you do equate this, right, what happens is, right, when you equate Fn dash to Fn dash is what? 2n plus 1 F naught dash 2 times 2n plus 1 F naught. Actually, this 2n plus 1 cancels. F naught dash is equal to 2F naught. That is why straight away I considered the fundamental frequency is equal to 2 times the fundamental frequency of this guy. Okay, and then simplify. Hope you understood that properly. Right. Right. So the rest of the question, this is a beat frequency question. If you see, right? So it's a beat frequency question, and once again, this problem is also going to be a beat frequency question, right? So therefore, I will skip these things. The 25th is not a beat frequency question, but obviously this is a very basic question, right? So like, I mean, like you have to prove the theory and all, right? So in that case, I just will omit this problem, right? So you can work it out if on your own, right? So like a very simple question, right? So fine. I think that is it, right? So we will meet on with the next tutorial session.